For the second part of our session today, we're going to start out with a very entertaining speaker. And he's a good guy, so he could probably entertain you on his own, but the topic is something that I feel it very much turns me on. I did a study in 1958 about the scaling of electronic components and what the implications that would do on technology for information processing, because I was assuming we were going to just need huge amounts of it. And that study just affected me a great deal by what it taught me about the changes that happen when scales change. A lot of these changes are things which you normally, if you work in one scale, you just don't think about it and you get surprised, very surprised. So, and it taught me that if things get smaller and smaller, you'd shift from different kinds of technology to make a device to other things that would be available at that size. So then about 12 years ago, I met Eric Drexler and his nanotechnology pursuit, and it was just, I just instantly, that's right. So I've become a total believer that that's going to change the world immensely. And in another channel, I met Neil Jacobstein. I'm learning how to pronounce it at the end. I met him several years ago, 5 years ago, I guess, when we were part of ARPA again for a period of time and got acquainted like him. So he's been involved enough with the nanotechnology people and with his background, a different slant of interest, that I think he'd just be a very, very good one here. So I'm very, very pleased to introduce Neil Goldstein.
It's okay. Pleased to be here.
Oh. Sorry. Boy,
no problem.
That's terrible. Good. I think I'll just leave.
Many of you are already familiar with molecular nanotechnology concepts. For those of you who are not, I will briefly review the concepts, talk about some of the upside and applications that are possible. Then I'll review some of the risks that are not normally talked about in the research community. And then we'll talk about some guidelines for the responsible development of the technology. Currently, molecular nanotechnology is a research and development activity. It hasn't quite happened yet. We have 2D nanolithography, molecular electronics, lots of nanoscale activity. But specifically, we are talking about precise, inexpensive control of the structure of matter. And we're talking about the ability to fabricate 3D aperiodic structures or irregular structures that are specified with atomic precision. And of course, they don't violate physical laws. What we're after is the ability to pick and place molecules exactly where we want them. I believe that when this occurs, we will have a revolution in our relationship to atoms as fundamental as computing was in transforming our relationship to bits. This goes back, way back to 1959, to a talk that the Nobel Prize-winning physicist Richard Feynman gave at Caltech, where he talked about the plenty of room at the bottom, where he said, the principles of physics, as far as I can see, do not speak against the possibility of maneuvering things atom by atom. It is not an attempt to violate any laws. It is something in principle that can be done, but in practice, it has not been done because we are too big. Well, it's not clear that the reason we haven't done it is because we're too big. I think he was joking about that. Clearly, we have feasibility examples in the biotechnology arena. We have photosynthesis, which grabs carbon dioxide, cleaves the carbon, releases the oxygen, synthesizes glucose, polymerizes that glucose into cellulose, and thus we have wood, which we use as an indigenous building material almost everywhere. You may be amazed that the reason why our houses deteriorate so rapidly is that the termites that attack our houses have the enzyme that cleaves the cellulose back to the component glucoses. We're basically building our houses out of candy. So we also have the example of people who start out as fertilized eggs and 9 months later turn into gurgling babies. These are examples of control at the molecular level. The state of the human technology practice, however, is much more primitive. We can manipulate individual atoms with scanning probe microscopy, but that's currently a very primitive practice, as you shall see. The applied science foundation for molecular nanotechnology has already been laid out. It was done so by Eric Drexler in an excellent book called Nanosystems in 1992. I recommend it to any of you who are interested in diving into the details. Over the past decade, the feasibility debate has shifted from nanotechnology is impossible, it's science fiction, to really a debate about how are we going to do it and when is it going to happen, not if it's going to happen. And for the details on the debate, I have some URLs for you. They include IMM, the Institute for Molecular Manufacturing, and Foresight. This is an example from IBM Zurich of the ability to move individual molecules with scanning probe microscopy. You can see in the box up at the upper left here, we have a lattice of 6 porphyrin molecules. They're composed of about 173 atoms. They run a scanning probe microscope tip through them to break them up, and then they reassemble them down at the bottom in number 6 here on the bottom right into a ring structure that is not typically found in nature. Ned Seaman at NYU has utilized the sticky ends of DNA to get DNA to self-assemble into a octahedron shape. This is actually a truncated octahedron that can be used for a platform for building other molecular structures. Richard Smalley's group at Rice University has been working with carbon-60 or Bucky balls. They form Bucky tubes from these Bucky balls, and these tubes have amazing tensile strength, and they can be used also as very sharp tips for a scanning probe microscope. And you can see in the slide marked A, this big structure here is the former tip for this very precise device. And over here, we have a Bucky tube that was basically adhered to the old tip using glue. And the new tip is 5 nanometers in diameter and 250 nanometers long. It is a very sharp tip. Long before the capability has come into play, Eric Drexler and Ralph Merkel did some design ahead for a planetary gear at the molecular level. They went so far as to simulate the properties of this gear. And if you look at the Zybex site, Ralph Merkel has an excellent set of URLs and resources for exploring nanotechnology at the molecular level. Wet chemistry today largely depends on controlling lab conditions like temperature and pressure and pH so that large statistical aggregates of molecules will react to form some yield of reaction product. But the central goal right now of molecular nanotechnology is to develop a molecular assembler or a positional controller that can act like a set of hands that will put molecular parts exactly where we want them. These assemblers could vastly increase the range of structures that we'll be able to build. And when we get to the point of being able to build these things so that they can self-replicate, we'll be able to drive costs down dramatically and achieve industrial scale manufacturing. Here is a proposal from Eric Drexler on a molecular positional device or an assembler. This is based on the concept of a Stewart platform with 6 degrees of freedom. So the question, when will molecular nanotechnology happen? When will it happen? It really depends on what kind of nanotechnology you're talking about. If you're talking about nanofabrication and 2D semiconductors and some molecular electronics and biotechnology that is a form of nanotechnology, that exists today. But the 3D atomically precise pick-and-place capability is not here today. And how long it takes to arrive will depend on our capability infrastructure, like Doug has been talking about, on research funding, and on how fast the technology will evolve. If you look at the trends in computing hardware and do an informal poll of the nanotechnology research community, usually the answer you get is something around 15 years from now we'll be able to see this technology really hit hard. Sometime in the 2010 to 2020 timeframe. It will happen, and when it happens, society will experience explosive changes. We think we need to begin preparing for those changes now. So I'll briefly go through applications in information systems, building materials, medicine, environment, space industrialization, and defense. When we get the capability, we'll be able to pack more computing power into a sugar cube-sized device than the sum total of all the computing power that exists in the world today. We'll be able to store more than 10 to the 21st bits in that same volume. We will have the equivalent of more than 1 billion Pentiums operating in parallel. Instead of using photosynthesis to create cellulose or wood, we could extract carbon atoms from CO2, and we could polymerize the carbon atoms into a sheet of diamondoid materials. Those materials could have a tensile strength that is 50 times the tensile strength of current metallic alloys like titanium. This will drive down the costs per kilogram of this kind of building material to about 10 to 50 cents, and it will enable us to do some things that are currently unthinkable. Whether we do these things or not will depend on our capability infrastructure and our values. But we will be able to rebuild cities, distribute abundance, and industrialize space. In the medical arena, disease and illness are caused primarily by damage at the molecular and cellular level. Molecular nanotechnology will enable us to build surgical tools that are molecular both in size and in their precision. We'll be able to embed computers in these tools, and we'll be able to do cellular repair. Today, the inability to repair cell structure means that loss of cell function results in tissue deterioration. So the function has to be preserved. In the future, when we develop cellular repair systems, we will be able to restore cell function if we have a blueprint or a map of the structure. And thus, we can use structure as a guide to restore function. That will be a real revolution in medicine. In the environment arena, most pollution today is a byproduct of dirty manufacturing, transportation, and energy production. We are not picking and placing molecules exactly where we want them. But since molecular nanotechnology is atomically precise, we will have a zero-emission manufacturing technology, or transportation technology, or energy production technology. And if you ask Paul Ehrlich, he'll tell you that environmental impact is a function of population times affluence times technology. We know that we already have a fairly large population, over 6 billion. In the future, that will grow geometrically. Eventually, it'll level off, hopefully sooner rather than later. But any way you look at it, we have to focus on the technology end of this equation to try to get zero-emission technology for lower environmental impact. Molecular technology could also be used to disassemble toxic chemicals into their component parts. It could also be used to redesign our fundamental housing, transportation, and energy systems. Currently, space industrialization is blocked by the high cost of vehicles and payload, shooting them into space. Molecular nanotechnology will enable us to launch vehicles that have a structural mass that is reduced by about a factor of 50. And the cost per pound for creating that mass will be under $1. So we'll be able to reduce the cost to low Earth orbit by a factor of better than 1,000. This came out of a NASA and National Academy of Sciences study in 1977. This is a quote from Admiral Jeremiah, who is a retired vice chairman of the Joint Chiefs of Staff. In 1995, he said, "Military applications of molecular manufacturing have even greater potential than nuclear weapons to radically change the balance of power." So if you can design and manufacture nearly everything that you can imagine, you also can design and manufacture weapon systems or intelligence systems, security systems. So we have some risks to go along with the upside opportunities. Dealing with those risks really means that we have to consider what the range of risks could be and think about using our newfound powers wisely. Molecular nanotechnology could be considered a weapon or a potential weapon of mass destruction, similar to chemical, biological, and nuclear weapons, or it could be considered a potential environmental hazard because it could be intercalated into DNA or introduced into biological cycles in undesirable ways. This creates the potential for very reflexive and uninformed government regulation. They say, oops, there's a risk here, let's regulate. What we're after is some foresight in the development of this technology, and we're after seeing if we can educate researchers about the potential risks, introduce development guidelines, and see if we can encourage the research community to self-regulate early. This happened in 1971 in the biotechnology community, and it was done remarkably successfully with the advent of the NIH recombinant DNA guidelines. So our community, that is IMM and the Foresight communities, are focused on the unprecedented benefits of molecular nanotechnology, and we're simultaneously addressing the risks, rather than addressing the risks as an afterthought. If you look at this ellipse as representing the possible structures that could be built with molecular nanotechnology, you can see that some of the structures that could be built have some undesirable characteristics, and the reasons why really have to do with the fact that they interact with the biological world. Living things have co-evolved internal components and external ecological interactions. These interactions are still poorly understood. And we know that in the last century, humans released thousands of synthetic compounds which still interact with organisms and ecological cycles in unplanned and often damaging ways. So molecular nanotechnology systems and products are going to interact with the biological environment. We know that now. So it's incumbent on us to understand in advance, as best we can, how to deal with that problem. The problem is one of interacting with complex control systems that have evolved over 4 billion years. Many of nature's components are ad hoc. In some cases, from an engineering perspective, they can be improved upon. But any of our improvements have to fit with the environment. And humans have a tendency to make linear connections between point A in a big tangle of complex interactions and node Z in that same tangle of interactions, and just draw a line from A to Z, cutting across all the cyclical interactions. That can have disastrous consequences. So what we're after is being able to interact intelligently with nonlinear and extraordinarily complex control systems. This is a major challenge for our capability infrastructure. It's difficult to do just one thing and not cause system-wide consequences. We tend to call those consequences side effects, but they are not side effects really. They're just effects in the systems we're interacting with. They're only side effects from the point of view of our linear human purposes. So what we have to do is pay attention to the possibility that we may be improving the system in one dimension and degrading it somewhere else. This is something we can anticipate now. And so what we ought to do is look at the range of possible consequences and start doing some design ahead. It's very clear that we'll eventually have laws that will require us to do this. long before there'll be any laws requiring us to think about these things, in February of 1999, a group of people from IMM and Foresight got together to produce principles and specific guidelines for the responsible development of molecular nanotechnology. The participants are listed here on the bottom. Tanya Jones is here in the audience. She was one of the people that joined us for that workshop. What we were after is some look ahead. We wanted guidelines that were similar to the NIH guidelines for recombinant DNA. Those guidelines, as I mentioned before, were remarkably successful. In fact, so successful that they were relaxed over time because the researchers were too conservative with regard to their guidelines, and they found that they could be a little bit less conservative after they had gotten some experience in working with the technologies. So some examples of design guidelines would include things like in these molecular nano devices, we could create an absolute dependence on a single artificial fuel source that does not exist in the natural environment. We could do hazardous experiments inside of a sealed assembler lab. We could make devices that return to an off state automatically. Like when you take your foot off the gas pedal, it returns to an off state. And it could depend on a broadcast transmission for replication, or in some cases, a broadcast transmission just for operation without replication. We could route control signal paths throughout a device so that subassemblies won't function independently. And we have actually quite a few of these guidelines. I've included them in an appendix to these slides. So in summary, I believe that for the first time in human history, we may be developing tools as powerful as our problems. But if we don't learn rapidly how to use these tools responsibly, undoubtedly the consequences will be severe. Developing and using these tools effectively will require the capability infrastructure that Doug and Bootstrap have talked about for years. What we're talking about here really involves tools, information system tools, to build tools and to use them wisely. Molecular nanotechnology will happen, and it will transform the playing field for humanity. And if you'd like to participate in the dialogue to help make the transition responsible, join Bootstrap, Foresight, IMM, and participate in this transition. Thanks.
I couldn't. You earned your fee. So anyway, this is very exciting to me. Is this on? The switch says it's on. Anyway, I needn't talk long because what we've coerced Kurt Carlson into giving an extemporaneous little talk. And Kurt has been the president of SRI for a year now, and has been friendly about things like this and has some history of working with the Defense Department about biotechnology hazards. And so, do you want to talk from there?
So, listening to Neil's wonderful presentation, seeing how well points out that there is a remarkable divergence about what happens. Nanotechnology on one side, what comes to us, and of course the developments in biotechnology, which are basically decoding us so that we can understand basically the information content that makes up all living things. The problem is that, as Neil pointed out, you'd like to know the interaction of the devices Neil was talking about with us. And understanding us is a very difficult problem. One of the most difficult problems we've ever encountered. So we know today that people are decoding the DNA, and that's a big job, but that's frankly a trivial job. The next big job that people have started on, just begun, is decoding the differences that make up all of us, called SNPs. But basically, every one of us is unique, and that needs to be understood too. But the truth is, even when you know everything about the human genome and everything about the genetic variations that are in the human population, those are still trivial problems. The real problem is what's going on inside of us. What are the interactions? What are the biological pathways? What are all the different ways that all those different genetic variations, what do they mean inside of us? And frankly, you need to understand those if you want to address Neil's concern, which is if you're going to build devices and put them out into the world, how are they going to interact with us as organisms? And frankly, it's obviously not just us. It's every living thing on the planet. And that kind of a problem interacts really, I think, very directly with Doug and his entire theme in this conference. It's a job that cannot be done alone. It takes cooperation around the world to address a problem of that magnitude. It requires organizations that can develop technologies and processes so you can do that better and understand it quicker. And it requires C-level organizations so you can learn from what's going on to even do those better. Now, what's interesting, though, is if you imagine you created a database that allowed us to understand us and the implications of everything that might happen to us and how to modify us in ways to prevent disease or just to change us to keep up with developments in nanotechnology, we're talking about a very interesting database. It's obviously the most important, valuable database that's ever been discovered, developed in the history of mankind. It is the database of life. Now, that database can be used for lots of good things, but it also could be used for lots of bad things. And this goes back to Neil and Doug's major point, too, which is that it's not enough just to assume that this database will be developed. Other groups need to be brought on board and think about the use of that data in other ways, politically, socially, and morally. And I profoundly agree with Neil's observation that it behooves all of us to start developing those relationships and confronting those issues now before they come upon us and things happen that we don't like.
I think I'd rather listen to them than me. Thank you, Kurt. So we try to take the scaling effects again. I think it's good for us to get hit over and over again by the scale of what's happening. And this says if we're going to learn to cope with that, then the scale of our picture of how to approach that has to be commensurate with the scale of the problem and issue. So that's why it keeps coming back to talking about strategic approach, and that it isn't something that you can just walk up and attack. You got to get a lot of cooperation. You've got to get a lot of input. You've got to, anyway. So many of these things then did come about that it's the collective knowledge, the collective capability within groups of people that it becomes important in this case. And so that's why it starts so early that I said that was be my career focus, is trying to see what can be done by that collective power. But just pursuing that alone is a scale of a challenge that's very big. And it isn't going to be something that you can write a proposal and get a project, 10 million, 50 million, 200 million, whatever it is. It's something that's more akin to getting to the moon was, or something. It's a big thing, and it needs a architectural approach and concepts and pursuits. And it's something, though, that would be good, because a lot of the things that people assume they'd like to have in the world are going to be dependent upon how collectively we can be able to handle complex, urgent things. So anyway, in the 60s, I have to say that I sort of got jolted a little bit out of that thing. I'd been hanging on to it. That's the pursuit for me. And so people were talking not only about the drug scene or things like that, but openly about spiritual approach. And if the whole world became Zen or something like that, or some such thing, then we wouldn't have these kind of conflicts or problems. We could proceed peacefully and in time to do things. And I thought, oh, maybe I ought to give up what I'm doing and do that. But then I got to thinking that the thing about organizing the world in order to shift to that is something that calls for a lot of collective action, isn't it? Oh, so very soon I was right back where I started from, was saying, okay. And another one, I started making a slide today, if I can find it. I was just saying, okay, so you can make a social organism that's smarter. That's good. But how about its ethical nature? How about corruption? How about all the things that human sort of personalities get aberrantly fixed on? And how about, you can be very, very, very smart but be narrow-minded, and so prejudiced you can't move. So anyway, it's many aspects of human organizations and their human conduct aren't something you're just going to cure by getting smarter. But getting smarter will help us find collective solutions. That's just been my bit. So anyway, I think this is where I was in my sequence of slides when we shifted. See, I had this great excitement of this weekend. 2 days ago, my laptop started making grinding noises, and I just knew if I went to work and made a slight things that they'd go down. But and so I found somebody that would loan me a machine for a couple of weeks, and to transfer that. Then I found out there are more and more things that I needed to get tuned up in there. So Shinya Yamada, where's he hiding? Anyway, yeah, there he is. He spent hours and hours and hours getting it like that, but it ended up we forgot to get the printer driver in there. And so when I came down to getting all this together, I couldn't get it printed out so I could get straight about what my sequences were. So I was lucky to get slides together. So how I augment me is a continual problem. Especially as I explain to you guys that I have these recurring senior moments in which I just forget. So, assuming that this was about where I left off, what I wanted to do was point out to people that via the web there are a lot of documents and papers that were written back in the 60s and 70s and 80s and 90s that bore on this thing, and some of them were quite a bit of painstaking description for these and the terminology developed and such. So I just wanted to give you a picture here of how you can go looking for them. That this URL at the top is a general one that goes to what we call just a library page in our web. And then every entry in there has a access number on it that's coded in as a what's the term? A target tag? Something like that. And so these happen to go along with the way in which our dear old augment system automatically gave access or location numbers to different of the statements in a hierarchy. So you'll see down the row of these things, 2A1, 2A2, 2A3, 2A4. When we extracted this from augment, it was put in there with these things as name tags. So in augment they're addressable. Every paragraph is addressable, and then there are also conventions for addresses to go to any character, any word, anything like that. And I should say while I'm at it that there are conventions in there, so if you want to describe a path between this link you're having and some object in there, you can do something like say, oh, I want to go to Christina's file so-and-so down to a certain place in there, and there's a link there. And she's going to have that link aimed at some good place all the time, and every time I click on this link, it'll go there and take that link. So they call it indirect addressing in programming, but we built that in there just almost 30 years ago, I guess. It's been a standard thing. So there are quite a few things in that system that were built assuming that we'd be much more aware of the kind of properties we'd like to have in our knowledge containers and the likes of functionality we like to have as we fly through and manipulate these things. So from time to time we'll sort of introduce more of those things. So today we're just introducing that that library has these particular characteristics to it. And so if you substitute after the pound sign in this URL in the heading there, this location number that's at the end of every one of these citations, then it will, a link on there will take you right to the library document and right to that particular statement. And then you can choose to go click on it and go see if you want to. Unfortunately, HTML and such, or XML, I don't know yet whether it has indirect addressing or not, but where's our XML? Does it yet have indirect?
There's an adjunct specification called Xlink that has most of the advanced linking features.
Yay.
Yeah.
How soon?
Actually, that's been through several public working drafts. There's a recent working draft that you can get on the W3C website. That would be at www.w3.org/R for technical something or other, I forget, reports or something like that. And if you just search on Xlink, and you should find it. There are two parallel things from the same group, Xlink and Xpointer. They're hung up in the final throes of getting everybody to sign off on every feature. So it may take another few weeks or even a month or two before those are made actual recommendations. But if you just ignore all that and take the current working drafts, you'll probably be fine.
John Bozak, Sun Microsystems, sort of was the founder, I guess, of the XML working group with the World Wide Web Consortium. And we're just very pleased and honored to have him come and attend our things, because, as we'll talk about later, this thing of embedding the properties you want inside your knowledge containers is currently the move is that they're done by this markup language called XML. It's a trend towards that, which is very good. And the coordinated, the functionality that you want to employ in these to go do unusual new things is sort of separate. It has to depend upon it. But the open source software evolution like that holds a lot of promise. So we'll talk about those things later. But meanwhile, back on the track we have here, that these different documents in there, so it starts with a list of what's in 1995. The 1992 article has got a pretty good explicit description through page after page of the sequence of scaling, of improvement infrastructure, of etc., and the bootstrapping, and talking about an open HyperDocument system. So there are allusions to this open HyperDocument system in our documents going back like almost 15 years, I guess, when at McDonnell Douglas we began to realize that there was no way that the industries could work without that sort of thing growing. So it's still a kind of thing that in this collective action towards the strategy that we have to find a way for that to evolve, and I think that there's a little bit more than what the World Wide Web Consortium is doing today, and we can talk about that later. But anyway, so in 1990 there was this definite explosion in this one thing of knowledge domain interoperability in an open HyperDocument system, and go see that. The 1988 one was a very complete description through the years of what we were developing in our laboratory. Then the 1984 one here, and the 1982-84s talked about the provisions of both collaboration and authorship, which was the basic stuff going. So if you want to sort of feel where I'm coming from when I talk about, hey, there's bound to be a lot more you can do to make effective the knowledge management, the knowledge work, the integration of the knowledge, etc., than what we're doing today. It stems from evolving systems and applying them day after day within a lot of aspects of groups, including the software developers, that we're actually doing those things. So I just have huge intuitive faith that they're there to go after, and the things we talked about at least should be good candidates to put out in the front for doing it. So here's some more of these references that go on. Sorry. We have the secret language. These two guys I depend upon so much. I just realize every day how much having people around who really can get things done, that without that I somehow tread water. I don't know what it is. So anyway, these papers are worth pursuing. And here's just examples of browsing in towards that library, that you can browse to the publications sheet there, and then you can soon get to authorship provisions. And this indicates something like we talk about one of the provisions we're going to have is this journal system, which I've talked about before, but it's described in this field too. And in the things that we do in the augment, there was right from the beginning in the mid-60s was the optional view control, that whenever you're looking at any place in a document, there are lots of options you begin to learn you'd like to be able to apply, and very quickly and easily. So some of the basic ones were multiple windows, one line per statement, etc., like that. So we were showing you here in augment windows of a form we've got working now. You go to that same document and you ask for a view that just show me the top level, one line only, and for the hell of it, leave the numbers on here for that. And then this one is picked down here, is clicked on this item 7, is saying it wants to jump there, and it's also just added a couple characters for the view control. So the next one is you're at 7 and you've got a new view, and now you click on Windows with another view, the window views 7C, and bingo, you're down there looking at its structure, and you says, okay, I want to go here, and you can tell by the view spec that's offered there, I want to see everything. So moving around inside of there like that was just so much more flexible than just scrolling is. And how did I get back there? See, all these special views. Here's one that tells me I'm done. So what we're going to do next is part of what we intend to do in here is try to develop a repository that starts to mean something. And the audience, including you people and the ones out there that are web watching, we would like to have starting to help. So Peter has just worked manfully, struggled hard, and with other volunteers, putting together a prototype set of tools and conventions for an early repository that we could have, that we could start doing things. So we can start taking Neil's and Kurt's and John's links and put them in there with descriptions. There are a whole bunch of things about what are the interesting improvement communities out there that are going. What are people that are studying things like really interesting intellectual stuff about how you construct your thinking and how that needs to be portrayed in order to help you work with it. So we want to build all that. And the intent would be to build a repository and focus on the content of those kinds of things that are going on in the world, etc., that are important to running a NIC. So now we'll switch, since Peter had this marvelous experience inside the Millennium Project, and he's going to tell you now about the first conventions we're establishing. Did I give you enough time?
Right. Okay, I'm going to sort of take off my futurist hat and try being a sort of system manager for a while. Maybe you want to ask, what are you trained in? I wasn't trained in any of those. I was basically trained as an operations researcher, an industrial engineer, and then in business school in organizational behavior and personnel management at that time. I guess you call it human resources now. But I've been with systems a long time. I've been an entrepreneur, started companies, ran a software factory that had like 250 programmers. And so I find it a challenge to try to sort of get things going in a way that maybe would come slightly closer to what Doug wants. So going back to his slide, I mean, this is what he terms as the DKR. I mean, it's a set of recorded dialogue, intelligence collection, and a knowledge product. And I understand from Doug and from Marcelo, I get highly enlightened these few days when trying to put this together, that this whole thing is an iterative process with feedback, multiple feedback loops. And so this is sort of the prototype, at least the basic pieces that I believe needs to be put together. We had a team, some of our members are here, Frode, Tanya, Shinya over there, and Doug had like Norm Hardy and a whole bunch of people working with us. Essentially, we need to put together a front end, back end, some processes to get us started, seed contents, services, and architecture eventually. I mean, we don't have one sort of put together. And then a current status. What is the current status? That's Doug's terminology. I mean, his terminology is handbook. But then, I mean, it could be an encyclopedia, goals, plans, commitments. But essentially, this is sort of another view of how we've got an external environment, inputs in terms of dialogues and intelligence collection, some sort of an integration process, and then a sort of knowledge product with a current status, constantly available and dynamically changing. We've got a user interface system that would provide different views for different users. So that's, and this whole thing in the box is the DKR, and the sort of the process of it, the concurrent development, integration, and application of it is Doug's Kodiak. So sometime in September, Doug and Christina sort of drew on the board what they wanted, and I mean, we could put these requirements on the web for everyone, but essentially they've got like open, evolvable, integratable, cross-platform, scalable, persistent knowledge base, persistent interlinking, provision for migration. I mean, it has to be off the shelf, but then it's migratable into something, goes on. And I try to mimic those things by trying to grab what we have that's off the shelf, I mean, to at least get us started. So far, we've got at least the input part of it in place, hopefully. And this is where we stand. I mean, we've got a Bootstrap and Colloquium participant community here. And then, of course, we've got our Colloquium session, which is offered on campus, on the web, over microwave television. And then with each session, we've actually got like Doug's talk, some guest speakers, live participants. And with those, we actually have sort of 3 products that are coming out. We've got audio-visual that is archived, that's available as archived seminar on demand. We've got slides that are coming alongside with them. And then we're going to actually have transcripts of all the conversation, all the dialogue. Eventually, we might even work on synchronizing all of those. And then most of you probably is aware that we've got a weekly questionnaire with some questions related to each session and some requests for feedback. And then we've also put together an online forum under the mailing list called unref2 at onelist.com. And that's sort of the user interface that you're seeing. Behind unref2, actually we're sending it through Hypermail so that each episode of the discussion is now sort of converted to HTML, and they are all linkable. this is sort of how the AV and the archived colloquium looks like. For most of you who've been on the webcast, I mean, that's what you'd get, I mean, on a good day. And going to the online forum, I mean, for those of you who have joined, I mean, this is the sort of off-the-shelf, free of charge, live with the advertisement type mailing list platform that we are sending people to. Why are we doing it? I mean, we're doing it because, I mean, they've got administrative services that would save us a lot of time in providing our own. What else do we do with it? Of course, it provides threaded discussions. It supports link contribution. Any user can actually submit links and that are shareable. People can upload files to a sort of shared space, file space, and then it provides a polling and survey capability. And as I mentioned, we are making it linkable via Hypermail. So all the episodes of the discussion will be available as linkable HyperDocuments. This is the screen. I don't think anybody have submitted any links yet. I mean, this is a screen where you could be submitting links. This is one screen that it's sort of put together for people to submit shareable files. I mean, Hilary Lamont, our online TA, who's also coordinating the online contents on the DKR, actually has opened up various folders. Like, I mean, one folder for the next frontier, one folder for augmenting organizational intelligence, the organizational capabilities, one folder for leveraging collective intelligence, and so on. I mean, roughly corresponding to the weekly sessions that we are topicked under. This is another screen of a survey screen that the list owner can actually be sending out surveys on email, and people could vote or take polls on it, and it will be instantly available. And this is the screen where we have most of the online discussions captured by virtue of the use of Hypermail. Unref 2 sort of is all the discussion, threaded discussions are available and could be sorted by thread, by user, by sender, by dates, and so on. So what else? Weekly questionnaire. I guess a lot of you are familiar with this screen. This is what we have put together after each session. I mean, this week's questionnaire probably will be out tomorrow. I mean, we'll have a questionnaire that pertains to the session. And for those of you who have answered the previous surveys or questionnaires, you will notice that an online feedback is available instantaneously. The verbatim replies are taken out. I mean, we still need some processing probably to put them online for everybody's reference. So far, we've put it away. So, I mean, in lack of sort of the enough bandwidth to deal with them. I mean, but it will be available soon. So what are the seed contents? I mean, Doug was showing us sort of a Bootstrap Library of all the documents that have been developed through the years. I mean, starting as early as the sort of 62 paper, was it? And the Bootstrap Library will be available. The Unref 2 postings will be available. Actually, you could now access it at www.bootstrap.org/DKR/discussion. This, however, this area is password protected. For all of you who have access to the webcast, I mean, you have access to this subdirectory. It's the same pair of username password that allows you to get into the webcast. Reason why we're doing it is, I mean, a lot of people are using their real name, and we just hate to have sort of some spammer come in and mine or the whole mailing list of the community. So it's under sort of a fairly simplistic authentication process. We would be making excerpts from the 1999 State of the Future report available. I promised Doug that we'll work on getting it in the augment format so that it will be anchored and sort of addressable, not in terms of the document, but in terms of every single paragraph. The State of the Future report is a very dense document, and I think it would give a good demonstration the real need to access inside a document rather than just telling people this is the URL for the document when it's a sort of 50-page document is close to being meaningless. Responses to questionnaires, as I said, that will be made available once sort of the team or some of us have the time to work on it. Services that we are getting sort of between ourselves, and a lot of it supplied by the OneList mailing list, is like membership administration. There's a group calendar which also provides a reminder for those of you who have actually signed up on the Unref2 mailing list. You probably got a reminder yesterday telling you that the session is on today. That's automatic. It saves us a lot of time. Survey and poll results again, and Shinya over there has just sort of put together our search capability, and once that's becoming available, we'll be advising everyone through the website. The search would be for the Colloquium site, the DKR site, and the library site. The DKR site is password protected. The Colloquium and the library sites will be publicly accessible. Of course, then the Bootstrap site is open and freely available. That's sort of the membership screen. That's the calendar screen. And where do we stand now? With the Colloquium, last week I was telling everyone that we had like 987 registrants. As of yesterday, we've got 1,243 registrants. On campus, we've got like maybe the first session was very high. We've got a big crowd. About 85 people were sort of overwhelmed this room. The session 2 and today we've got roughly about 50 people. We've got sort of about 100 people responding to the first webcast survey. That was a test and also sort of a drive to try to help people get onto the webcast smoothly. We've got about 94 people responding to the first session questionnaire and 71 to the second session questionnaire. 120 people have joined the online forum now, of which 24 of them have made postings, sort of a total of like 60-some postings. 61 was the count as of last night. Obviously, there's a big discrepancy between registrants and people who have joined the community. So, since I'm online, I would like to sort of call to everyone who has registered for the course that participation through the online forum is very useful and will probably be a part of sort of active participation, so please join us there. And also, filling in the survey is a requirement for the course, so please take note. So what do we need? Doug was saying, we need a lot more support. Obviously, we need content contribution. Please, there will be no dialogue if nobody speaks up. And then past that, we need like administrative support, maintenance, database, version control systems. We need architecture and design ideas. We have actually formed 2 teams, in preparation of the colloquium. One we call the infrastructure development team, which sort of looks at the technology and the processes, and which Throde and Tanya over there are part of team Shinya too. And then we need a content development team and we've got Hillary, Marcelo, and with this team, we need like people who works on the knowledge. And if we were to come up with a handbook or an encyclopedia-like knowledge product, I mean, we need people to be editors, I mean, to filter and integrate those knowledge. So essentially, that's where we stand with regard to the prototype DKR. Back to Doug.
Thank you very much. It's sort of an abstract plan to say at some time, if there ever is going to be a move like this, someplace it has to start. And we've tried to get it started in the past by writing proposals, and somehow peer review somehow drops the potential, apparently, of what we're doing with that. But some way, we're just hoping that we can start, and it'd be small and primitive, but we can get people going on it and staying focused on collecting and integrating the kind of knowledge that's what would be needed to support NICS. Seems to be the best place, and it's the best strategy or something like that. So that's what we're doing. So anybody who really is interested in kicking off NICS in his world would, a NIC kick, I don't know, but anyway, maybe we can get some resources, and people resources and dollars. And no one knows how much it would cost to set up a trial system like this that really does stay dynamic for a reasonable knowledge domain, like what we're talking about, apparently reasonable. And so, you know, the estimate could be running the saying, well, you could spend $1 million a year, or $5 or $20 million a year. That I don't know of anybody who's got enough of a grasp around the dynamics of that problem to know. So it'd be just very useful just to build one, and especially if the knowledge product you're trying to produce is really useful. So anyway, this is the hope. Next week we talk more about this open HyperDocument system thing and some of the dimensions on which it'd have to be established in order to get the evolutionary situation under control. Maybe that's a bad term. Getting the evolutionary situation under control, it just getting it so it's operating in a well-evolving way. So we'd like to have people stay around and talk. We like the dialogue. We like to know where your heads are and such. So does anyone have any particular question? We have a few minutes. And you use the microphone so that people out in the world can hear?
Sure. I believe that you have said last
Identify yourself, please.
Okay, I'm Marcus Krumenacher. I have mainly an interest in nanotechnology and biochemistry and computer science background. I think last week you mentioned that occasionally you still are using the NLS augment system. So that raises the obvious question: on what platforms does that run nowadays? You know, could we get a hold of a copy of it? Could we see a demo of its advanced capabilities? I think that would be, a really great illustration of what kinds of capabilities have been around for a long time that we still generally lack.
We thought about doing demonstrations during the colloquium, but it turns out that the dynamics of that wouldn't propagate out there. So for local people, we probably will, and if somebody can get a video record way of that, that would be beneficial. The platform is now, the last implementation of it was running on a DEC 20, which was like a 1970 machine that lasted for a decade. And so some very good supportive friend, not for and some other reason, he made an emulator that runs in Unix that emulates that machine. So every machine instruction has to get interpreted into a whole bunch of sequences itself, and yet still it runs twice as fast now on a reasonable Sun workstation as it did there, and newer ones would go even faster. So we keep it alive, and Christine and I and a few others use it every day. It's just hard to give up, and we could give a demo which would be very, very good. We've done that in the past, and several times for a week we'd say, come and we'll start showing you. So we through the day we cycle through about 5 times. We show them some features and let them play with it, and it takes a whole week and they're still not done, but they've learned enough. So we could give demos.
What about what about your?
Would you identify?
Dave Crocker. What about your demonstration tape from the '60s?
Sure.
That you did at IFIP conference, or I can't remember exactly.
No, that was the Fall Joint Computer Conference.
Oh,
We
yeah.
have that, and another one a year later, and several others we've done in the
But
past.
that might be something that could go out over the air.
Yeah, we'd be happy to do that.
Actually, I was actually wondering just the other day whether it was possible and how it would be possible to obtain copies of that video.
Oh yeah, the 68 video we've been having on hand, we could reproduce for people for a price. And
Doug, you might actually make some money off
oh,
this.
right. But it'd just be fun to next week to tell you a little more about the kind of things it can do, and the very fact that we got it structured into hierarchical form opens up things you can do, like it's very easy to sort and stuff, because you can sort all the brothers and sisters along something. Well, then you can do content analysis very simply and easily. Well, you can sort on a content analysis, so pretty soon you learn the tricks, and you can sort on date even though the dates are mixed in position in a paragraph, or anyway. But it's so okay, we'd like to try that. So after this series we might schedule some demos that'd be handy. It'd be good for us to do that. So,
Marcus Kromenacher once more. Is it possible for this emulator to get downloaded, or the source code to be made available so that it could be ported to Linux as well?
well, it belongs to a private party, and we could ask him what he wants to do. He did it for a commercial, hoping he could sell it. He sort of gave it to us to use, but we're not free to give it. And I think he has it running on Linux now, which would be very easy. And you get faster machines than we have. It'd be Flash. I'll bring the key set we have to use. I mean, that's the option that makes it really fly sometimes. Okay, your name?
Yeah, Eric Armstrong. One of Peter Yim's slides mentioned KQML. I was wondering, what is that?
Use the microphone.
It's not my slide, but I mean, I'll make it.
Query manipulation.
Right.
Right.
Knowledge query manipulation language. It's part of the DARPA program. It was developed under DARPA auspices, and it's an inter-agent query language.
Does it look like SQL, or does it look a whole lot better? I mean, what can you say about it from an evaluation perspective?
Next week there'll be
It's
some.
built on a set of primitives for communication, and you can look it up on the web. There's quite a bit available on it.
Well, the next week we're talking. Excuse me. Okay. Next week, that sort of special focus is on the technology. We could try to make it so that a lot of it stays general enough that it gives non-techie people the feeling for some of the potential and some of the architectural issues that would come about to try to do it that are different from today's. And then the techie people can get delicious because we have a mix of people with different backgrounds. And the thing will be to conduct that group through a meaningful thing. So really the thing is, what's the potential for really boosting the kind of power that skilled and trained individuals can employ in doing their knowledge work? And I just feel like it's very much higher than today, and that you actually can look at just very different ways that you approach the stimuli you give your sensory apparatus with signals that can be converted by your perceptual apparatus into the symbol association that language provides. But languages that we use them now, evolved in very noisy, different environments, different from the environment you can create when you're interacting with the technology. And also many aspects of that they could only employ certain kinds of sensory and motor and perceptual apparatus that you're using. So there just seemed to me that you set that aside a little bit and just open the gate for what you could really go out and explore. And I'd be willing to bet you that in 20 to 40 years, you'll find high-performance people that they just can, walk away from us, like a, I don't know, jet plane. That there'll be a great deal of difference, and human-computer interface people can open the doors into more. Anyway, these are my feelings, and their intuition, and I'm betting on it. So we have to close the gate. You got another one?
Yeah, Ron Goldman, I've got a question. When you talk about C-level organizations, I've got a confusion in my mind, because when you talk about them as a C-level organization, you talk about they're for improving improvement, and that makes sense. But then earlier when you're talking about
it's
this...
improving the capability to improve.
Okay. And then when you talk earlier, when you sort of sketch out the landscape of what's happening and where the organizations sit, you talk about a scouting function, being able to scout out the new domain. And those seem to be, to me anyway, to be two separate functions, and I'm wondering if they're two separate functions to you or if you see them as being the same.
Well, what C is there to do is to help improve the B capability, to do its change. So scouting that future is part of it, to help know where you want to go, and also help sort of say that by case studies and experience out there, you see that if you want to get there, probably the best way is like this. And so that, and then the sort of operations, like you need a wagon with 7 oxen or something. How do you get there? So that's something that'll be more and more expensive to get, and doing it collectively. Okay, I think you've been good. If people want to stay around, we like to talk. Okay.